factorial correction to this state. So it is nothing but the expectation value of v of x, v prime of x to this state. So phi 1, and gives 2 epsilon by a expectation value of mod x. Okay, epsilon by a. This is nothing but side to side, sinus to side 1. It means it gives 2 by a out, and indication of a by 2 plus a by 2 mod x and sinus side. It will be cos square pi x by a then dx. Okay, mod x cos square also real function, so you can change the limit. So 4 epsilon by a squared, it is 0 to a by 2 into 2 into 0 to a by 2 x cos squared pi x by a and dx. So it will be 4 epsilon by a squared and 0 to a by 2 x, not 2 into cos square something, of 2 cos square theta. So 2 cos square theta is nothing but 1 plus cos 2 theta. So 1 plus cos pi x by a dx. Now integrate it, so it gives one step and correction, factorial correction. So 4 epsilon by a squared, first term integration of x squared by 2, so it will be a squared divided by 4 times 2. Okay, the second term integration of this, it is 0 to a by 2. Okay, then x cos of 2 pi x by a. Okay, and dx. Okay, fine. So first term will be squared is cancelled. Okay, first term will be epsilon by 2. Okay, and second term is 4 epsilon by squared. Take the integration. So let's x as it is, 4x as it is, the integration of this. So integration of cos will be x as it is, a divided by 2 pi. It will be sine of 2 pi x by a, limit 0 to a by 2. Okay, fine. Then again, derivative of x, okay, negative sign, derivative of x1, then integration of this cos will be sine, again integration of sine will be minus cos, so this means plus a by 2 pi whole squared, so it will be sine and then cos of 1 square x by a, limit 0 to a by 2. Okay, so epsilon by 2 plus 4 epsilon by a squared, so if we put the limit, so a for case a by 2 it will be pi, so for the sine part it will be 0, and for the lower limit it is also 0 since x is high, and for the cos part for a by 2 it gives minus 1 now. Okay, so minus 1 for a by 2 and for 0 also minus 1, so it will be minus 2 of it, 2 a square, so it gives a square divided by 2 pi squared. But since there is 2 times of this, so in denominator there is 4 and numerator 2, so 2 to the 4, so you get these things. Ultimately expression will be epsilon by 2, a squared is cancel out, and it will be epsilon divided by 2 epsilon, basically 2 epsilon divided by pi squared. So this is the expression. From this we can say that what is the exact form. Now if we take common epsilon divided by 2 pi squared, it gives epsilon divided by 2 pi, okay, 2 pi squared, it gives pi squared minus 4. So option A will be the correct one. Okay, so it's option A will be the correct option. Now next problem. So suppose the spin degrees of freedom of a 2 particle system. There are 2 particle. Okay, system can be described by a 21 dimensional Hilbert subspace. Okay, now which among the following could be the spin 1 particle? So 2 spin particle here. Let's take one having spin s1 and another is s2. Okay, so for s1, what will be the dimension of the Hilbert space? It gives twice s plus 1, and similarly for s2 it will be twice s2 plus 1. Okay, so as a whole for the 2 particle system, total number of dimension will be 2s1 plus 1 into 2s2 plus 1. Fine, and given this is 21. Okay, so this 21 will satisfy if only when if it is 3, if it is 7, or if it is 7 uh, or it is 3. Okay, because twice s1 plus 1 is always a if s integral spin, it also gives twice s plus 1 as the integer, any integer value. If s is any half integral spin, so half integral spin, like if s1 is in by 2, so then 2 and 2 are cancelled, it can cancelled out, so therefore you get in plus 1, so it is also a also an integer. So that's why we can say as that if the product of these two is 21, then we can say there will be 3 and 7 will be 21. So maybe twice s plus 1 is 3, or twice s plus twice s2 plus 1 is 7, or vice versa. So if we take twice s1 plus 1 is 3, so then it gives twice s1 plus 1 equals to 3. Then s1 will be twice s1 will be 2, so s1 will be 1. Okay. Similarly, if twice s2 plus 1 equals to 7, then twice s2 equals to 6, so s2 will be 3. So for this two particle system, the spin of one particle will be 1 and another one will be 3. So option there is only one option 3. So option B will be the correct one. Okay. Now similar problem there there is another similar problem here. Just 2018, that the spin degree of freedom of two particle system non-zero, described completely by a Hilbert space of dimension 21. Same problem. So one is one there, I think one spin will be 1 and another one will be 3. So there only one option will be correct, that is option C. The same problem. Now, J 2017, so a particle described by the following Hamiltonian. Okay, this is the Hamiltonian part. So this is the uh, unparted Hamiltonian, and this part is the parted Hamiltonian. So it is basically summation of this is the unparted and this is the parted one. Okay, so where the quartic term to the power 4 term can be treated parted, okay, parted term, and if del E naught and del E1 denote the energy correction of the lambda order to the ground state and fast excited state, then what will be the ratio for the fast state and the fast order correction to the ground state and also to the fast excited state. Okay, so since it is by saying we can say that system is basically simple harmonic oscillator. Okay, yes, so for SAHO, this is the x to the power 4, and part of portion is basically lambda x to the power 4. We know that for x to the power 4, what is the uh, actual expression, the expectation value of x to the power 4. Since the first order correction is nothing but the expectation value of that part of Hamiltonian. Okay, fine. Now x is nothing but root under h cross divided by twice m omega in terms of lowering and rising operator, a dagger plus a daggers, a dagger plus a. Okay. Now if we operate x4 on in state, or we can find the expectation of x to the power 4 in state n, it gives basically h cross divided by twice m omega to the power 4 root under it will be squared, and here we get 6n squared plus 6n plus 3. Okay. Okay, so if it is for the ground states n equals to 0, then we can get the energy change in the energy, the first order correction, that is e0 del e0 del e0, the denoted the correction term. Okay, so del e0, that is n is 0 here, so lambda times for n 0, so h cross squared divided by twice m omega whole square. So for n 0 it gives only 3, so it will be 3 lambda h cross divided by twice m omega whole square. Fine. Now this is the first order correction to the ground state. Now this is the first order correction to the fast excited state. So first part of the fast excited state, n will be 1, so n will be 1, then what will be the expression for this, so m omega then whole square for n is 1, it gives 6 plus 6 12, 12 plus 3 15. Okay, 15 times of it. So if we take the ratio, that is del e1 divided by del e0, it gives nothing but 15 divided by 3, that is 5. So what will be the ratio? The ratio will be 5. This is the answer. To move to the next question. So just 2018 again. Now we have to find the difference between the maximum and the minimum eigenvalues of the system of two electrons. H equals H plus J times S1 plus S2. S1 S2 are the corresponding spin angular momentum operators of two electrons. Okay, fine. So H plus J into S1 dot S2. So let's take S, the total spin angular momentum is nothing but S1 plus S2. Okay, now take square, taking square both sides, so it will be squared S1 squared plus S2 squared plus 2 S1 dot S2. Fine. So S1 dot S2 will be half times, okay, half times uh, A squared minus S1 squared minus S2 squared. Okay. Now this AC is basically S1 plus S2 now. So half times S is S into S plus 1 minus S1 into S1 plus 1 minus S2 into S2 plus 1. Fine. So here S1 and S2 maybe H cross by 2 or minus H cross by 2. Same things for H2. But for S, since S is the addition of S1 S2, so for the singlet case, S will be 0, and for the triplet case, S will be 1. Okay, fine. 1 H cross basically. So if we put taking the common out H cross, so it gives h plus by 2 and same things. So now for the maximum value of it, s1 dot s2 should be maximum. So s1 dot s2 max, for max case, so it gives h plus square by 2. So this gives for one case, so ultimately 2 will be there, and half of it will be half plus 1, 3 by 4, so 3 by 4 will be there, and also 3 by 4 here, so it gives 3 by 2. Ultimately we get 3 by 2, 3 by 2 is there, and we solve, then it gives half only, so h2 square by 4. Fine, this is the maximum value. So minimum value will be s1 dot s2. For minimum case, if we take it as singlet, then it will be minimum. So for the minimum case, this part will be 0, first part, and the second part gives h plus square by 2 minus 3 by 4 minus 3 by 4, so so it gives the plus value, I think so. So this is the negative value, so negative half, negative negative half, negative half, negative 3 by 4, ultimately positive, and as a whole negative. So minus 3 by 4 minus 3 by 4, it gives minus 3 by 2, so it gives minus 3 by 2, then we get minus 3 h plus square by 4. Okay, fine, this is the minimum value. So what will be the difference? So difference will be max to min. So since is h will be the as it is, h is fixed here. So the difference between the maximum and minimum is nothing but the difference between this part. Okay. So max minus min will be nothing but sj as it is, s1 dot s2, max of s1 is s1 dot s2 minus min of s1 dot s2. Okay. So j, we take the max minus min case. So h plus square by 4 is here, and the second part it will be h plus square by 4. So ultimately it gives j h plus square. Okay, so the max min difference will be h only. Okay, next same problem. Okay, so for harmonic oscillator, the Hamilton is given. Same problem, same quadratic term is here, x to the power 4. Okay, so we have to find the ratio. Same problem, na? This is this one, same problem. Answer will be 5. Okay, same problem.